of my interest. I'm going to present some results on semi-submersible pipe floaters. It is meant for supporting an offshore wind turbine. So my lawyer is a student and completed this work and has joined a PhD student and knowledge. So I'm going to present a it has less turbulence intensity, smaller shear and shear than on land, no limitations for wind turbine, no visual noise effect. So when people installed this offshore wind turbine near the coastal community started complaining about huge noise producing. So people started moving the wind turbines far off the coast. No space constraints. So we need to design suitable floaters for supporting this offshore wind turbine. When we think of floaters, how it is going to give stability such a massive structure. And one, you can think of water plane area. The moment that the structure, the water plane area makes about the structure center of rotation. For example, is a barge. And they have a ballast stabilized floater. And the lower the center of gravity, below the center of buoyancy. That's the spark platform concepts. And actually, there is a floating offshore wind turbine spark which is existing. I think, if I'm not mistaken, in Denmark or Norway. And there is some concept based on TLP, restored moment at the mooring line fixed on the structure. So we can achieve floaters stability with all these concepts. What we took is we had three different types of floaters: a barge type floater, a semi-submersible type floater, a deep drafted column structured floater. And this is a part of the results of a semi-submersible type floaters. And it's different because we have four pontoons, and we had a parametric study of varying the height of the column, the height of the pontoon, the diameter of the pontoon, the diameter of the column. So that was the structure we had in mind for supporting the offshore wind turbine. Now the wind turbine we have considered as NREL 5 megawatts wind turbine, and it is not a real wind turbine but it's a concept. Its rotor orientation is upwind, variable speed, diameter is of 126 meters, the hub height is 92 meters, and the total mass we are talking is about 730 metric tons. So that is the NREL wind turbine they have taken for designing this floater. Now we designed the semi-submersible for the supporting the 5 megawatt wind turbine, and did hydrostability analysis for the floaters. We did hydrodynamic analysis of floaters using WOMIC. And once we did these two cases for the different types of semi-submersibles, and based on the ROs, we chose which is the best type of floater, what we think based on the ROs, and then we did the response analysis for different sea states. So this is the driving parameters in water plane area of semi-submersibles at the water plane, and then how much pitch motion to be allowed to limit 10 degrees beyond which the wind turbine loses substantial efficiency. And when we design semi-submersibles and compare, we have to compare on one platform. So the platform we took this fixed metastatic height of 1 meter. So we designed all the semi-submersibles with a fixed metastatic height of 1 meter. These are the load calculations on the rotor, the thrust motions, and what is the steady state field angle, and then what is the design restoring moment from the structures. So we analyzed 6 different semi-submersibles varying from square deck and a fixed GM of 1 meter, varying the diameter of the column to the diameter of the pontoon. And the floater mass has been varied from 2,280 tons to 2,400 tons, and the ballast was varied from 3,360 tons to 4,080 tons for the 6 different models, so that we have achieve the fixed GM of 1 meters. These are the different hydrostatic and mass properties of the 6 different models. The 14 diameters vary from 9.8 meters to 14.6. The pontoon heights, the column diameters to the column heights. Let me skip all this data. It's important to know that all these semi-submersibles are having a fixed metasurface height of 1 meter. And we did, the student did the modeling using multi-sub for semi-submersibles, and hydrodynamic analysis was carried out in warming. And one important thing to note is that while carrying warming, which is a potential flow analysis, this diameter of the columns somehow some falls into horizontal drag. So we have to introduce artificial damping to bring down the RAOs. So that was based on some of the experiments which was conducted previously, and where people use warming analysis for semi-submersibles, and then did experiments in the wave tank, and then they found what amount of damping we can introduce in the warming to bring down the responses. So the same concept was utilized here, and 4% of damping was reasonable to bring down the responses, huge responses produced by warming. So these are the results pertaining to the surge RAO for the different types of semi-submersibles of different diameters and column heights, the heave RAOs and the pitch RAOs. And from this, the flows of say D by D of 1.5 and H5 H of 1 produce the least heave responses. And if you compare the pitch RAOs, all are relatively small. This is for wave heading of 0 degrees. Then the same analysis was carried out for wave heading of 45 degrees. And we did again the response analysis using different wave data for the best semi-submersible program. And the environmental data for sea states, it was used the PM spectrum, which for 3 different sea states of 4, 5, and 6, corresponding to moderate, rough, and very rough. And the significant wave heights of 1.7 meters, 3.4 meters, and 5.3 meters are 3 different wave states, and these are the wave frequencies. So this was considered for the wave. And for the wind, we use the Harris spectrum. We used to calculate the response of the semi-submersible considering only the wave loading, and for the best semi-submersible floater, the response analysis considering both wave and the wind. And so the best floater we chose based on the RAOs were the D by D 7.5 and H5 as 1, and we consider the wave rating only. And this is for sea state 4, 5, and 6, the spectrum of the surge responses, the spectrum of the heave responses, and the spectrum of the pitch responses. And all are done in frequency domain, so you should be able to calculate the area under these responses to find out what is the HRMS and the H significant responses of the surge for the heave and the pitch for 3 different sea states. The standard deviation is also reported. So significant surge response height is 2.9 meters and occurred for sea states of 6 of the 0 degrees wave rating. Significant heave response height is 3.3 meters, occurred for sea state 45 degrees wave rating, and significant pitch response height is less than 1 degree for all the sea states. That is for the best floater. We included wave also, and there is significant changes in surge and pitches, because he was not affected. The significant surge response was 5.72 meters occurred for 6 safety states of 0 degrees wave rating. Response height significant heave is 3.63 meters, same, and the pitch response is 2.2 degrees and occurred for 6 states of 0 degrees wave rating. Silent conclusions. Hydrodynamic analysis was carried out using warming with artificial damping. So with damping from the experiments of about 4%, introduced in the warming, and then we did the analysis. On different semi-submersible floaters, aspect ratios ranging from 1 to 1.5, that is D by D, and H by H has a aspect ratio ranging from 1 to 5. Now all these floaters, the common platform is the transverse metastatic hydroscape as 1 meter. Now the semi-submersible floater with 1.5 and 1 yielded a minimum RAO in heat, and semi-submersible floater with D by D1 and H1 and D by D1 point and H1 yielded minimum RAO in pitch. And the response analysis was carried out in frequency domain, and the statistics are reported. Thank you.
Thank you very much. Everybody deserves some kind of question. Any questions from the audience? Yes, there is one. Yeah.
Well, actually, the semi-submersible is kind of rig, yeah? That's a rig. But my question is, what kind of, what's the section? It's circular or 6-side or 8-side of the, which better? Did you try compare between cylinder section? Yeah.
Now the columns are all circular only circular columns, 4 columns.
Yeah. Well, I think if say rectangular must be better than yeah, due to the multi-directional of the wave. So I think instead of circular, using rectangular.
Actually, maybe I'll buy the same thing from my next student.
All right. I'm going to ask my co-chairman, Dr. Zahurul Haq, to give me the directions for the area.
From the cafeteria. Okay, so is it in the cafeteria? When is the workshop? So I think the organizers better equipped than me.
Yes, gentlemen, we have a cultural evening at 7. It will take place in the auditorium building, and you can follow me. And right after the cultural evening, we will join the dinner at 8. Yes. Thank you very much.
I'd like to thank